Okay, I'm going to jump right in here just because I know that I am the last thing standing between you and freedom for the evening, so I will bear that in mind. My name is Sam Faus. I'm an associate consultant at Sujansky and Associates. We're a consulting firm in the Bay Area focusing on healthcare informatics consulting. And I'm here to talk to you today about Project HealthDesign and specifically the common platform and how that is enabling innovative uses of health data by personal health applications. So just to give you a little bit of context and background about what Project HealthDesign is, back in 2006, 2007, the Robert Wood Johnson Foundation had a new vision for what a personal health record could be. They wanted the personal health record to expand beyond what was at the time's primarily simple repositories. Thank you. Simple repositories of personal health data that was very clinical and specific and was essentially silos of information. And part of that vision was the implementation of cutting-edge, innovative personal health applications that could do really cool, interesting, beyond the imagination things with personal health data. So another point that they had was that in addition to capturing the common clinical types of data, they were interested in capturing and integrating what they call observations in daily living. These are less clinical types of information about a person, things in their daily life, what they ate, how they're feeling, what types of medications they're taking if they missed any medications, things that go beyond that clinical data summary that is stored in electronic health records. So in 2008, they awarded 9 grants to a variety of grantees and tasked them with the development of creating these really unique personal health applications. One of the requirements for that was that all of these platforms had to be able to communicate, to connect with a platform of some kind to enable the sharing of operational resources and this personal health data, these ODLs. At the time, there weren't a lot of options on the market. There were a few, but some of the big players that are on the market today, and we heard of one, Google Health, did not have their solutions publicly available. So they decided to sponsor their own development, and that was the common platform. And that's where our firm came in. They tasked our firm with providing technical assistance to the grantees and to assist in developing this common platform. So we elicited requirements, we designed this, we documented the design specification, and we oversaw the development of this common platform solution. So what is it? In essence, it's a personal health data repository. It enables you to store and retrieve personal health data, personal health application data, for mobile and web-enabled devices and applications. Technically, it's a SOAP-based Java Web Service architecture, and the requirements for this solution were all gathered specifically from the 9 grantees that were involved in Project HealthDesign. So it wasn't set out to be a commercial product with a business plan. It was really for the purposes of research for these grantees and to support the operation and interoperability of the grantees' personal health applications. So the underlying premise of the common platform is that many personal health applications, PHAs, require similar components and resources, and some of those include being able to capture medication lists, the recording of observations at home, maybe through a device or through maybe self-reporting over a smartphone or through a web application, They needed to be able to safeguard their data, not just safeguard it, but also make it available to the right people. And finally, they needed to be able to associate the right data with the right people. So taking all of those kind of general requirements, we came up with a solution of the common platform. And here you can see an architectural high-level diagram of what the common platform consists of. It's 5 interrelated services: observation service and medication service. Those are the 2 workhorses of the service. Those actually store the patient data. There's an authentication service to make sure that you can access the data, or that you're authenticated, and once you're authenticated, you can access any of these other services. A registry service that manages the creation of users, patients, and applications that can access the data. And then a centralized access control service that's separate from all of these that determine who can and cannot do what with which data. On the back end, all the data is persisted in a MySQL database. The solid lines on this diagram are publicly available web service interfaces made available through a WSDL specification. So you can download the WSDL, build your client code against it, and hit any of these services. The dotted lines are private internal interfaces that allow the services to communicate. And the original concept was that eventually those private internal interfaces there would be public interfaces that they would be made public so that you could implement one piece of the service outside of the rest. But the current implementation, those are still private. So some notable items about the platform. As I mentioned, single sign-on. So once you've authenticated, you can hit any of those other services using an authentication token that is returned upon a successful authentication. Important is the flexible access control system. This was a requirement that we heard over and over again from our grantees, that they didn't want to just keep their data available just to them. They wanted to be able to make it to control access to medical providers, to family members, but be able to have a high level of control over that access so that you can grant access to one thing but hide something else. A mix of clinical data types and these more patient-centric ODLs. So it supports lab tests, it supports allergies, but it also supports mood, how you're feeling, journal entries, medication administrations, meals and snacks. The data is extensible. We have formal definitions for the data, so they're all structured and defined by a schema, but we also allow additional information to be applied to these data types, because recognizing that different applications may need 1 or 2 pieces of information to be applied to data that we didn't plan for. So we made it extensible through our data model. Optional coding of data. If your application is reliant upon some standardized code set like a LOINC or a SNOMED, or name your coding system, our data structures support it. If your application doesn't need it or doesn't have access to a medical terminology, it's not required. So you can report a medication without having the full RX norm, CUI or whatever, or the NDC or UPC. Finally, every record medication observation can be annotated, essentially commented on without changing the source record, and it can have multimedia attachments, so you can attach an image of a pill or a voice recording over a journal entry. Here's the kind of the general data object relationships. At the very top is the patient, and the patient can have medications and observations. And as I just mentioned, medication lists can have attachments and annotations. The user there is kind of loosely associated with the patient. There's no direct hard relationship between user and patient, those are all maintained via the access control system. So you may be the record owner, the patient record owner, or you may have a different relationship to that. A user may have a different relationship to a patient record, may be a parent or a medical provider. And I'll talk a little bit more about the access control system in a little bit. So when we talked to the grantees and we're collecting their requirements, they told us that they want to be able to talk about a specific healthcare encounter, when it is, how it went. They want to be able to put in journal entries and maybe even, store text messages. One of the grantees took text messages and built a semantic web of how the person was feeling today against what their text messages were. Meals and snacks, what you consumed in a day, what pills you took, what pills you missed, physical activities and symptoms. We also have kind of more catch-all data types for doing things like lab tests and like glucometer readings, for example. That's that observable parameter generic data type. Then on the medication side, we have what medications that were prescribed, medications that were dispensed, and some ad hoc, like over-the-counter stuff, support for vitamins and supplements, etc. So these were all things that the grantees told us that they wanted. Here's a quick peek at the schema for a medication record. I'm not going to go into too much detail, just to indicate that we're building a lot of this based off of kind of what is commonly used in these data sets, looking at kind of things like CCR as a base model, and then building on based on the requirements of of our grantees. Here you can see the highlighted code optionality thing under the medication identity. That's how one example of how data is coded. So you could put an RX norm code there or not. A quick view of of the operations that are supported, what you would expect really. You can create, query medications in a couple of different ways, update them, delete them, and also there's operations specifically for annotations and operations for managing attachments for records. So getting back to access control is hierarchical. It's role-based so that you can assign somebody a role like a parent or a medical provider or a specific kind of medical provider, and the access rules that you write can subsume some of those roles. So if you say, grant all medical providers access to my record, then a physician, somebody with a role of physician, would get by default get that privilege. It's centralized, as I mentioned. The access control rules are available as a service, and all the other services query the access control system. So, just to give you an example of what you can do with this system, you can say something like, anyone who I say is a family member can look at all of my data, but they can't look at my journal entries, and maybe I don't want them to look at one of these medications that I've been prescribed, because I don't want them to worry about something. So that's a fast view of kind of what the Common Platform is. What we learned in round one of Project HealthDesign is that first, there's really no good authoritative source for ODL data types. Clinical data, yeah, there's been lots of work on what makes up a good medication or what makes up a good allergy record. But when we're talking about observations in daily living, there has not been a full review of what the right ODLs are and what the right data elements are there. Personal health applications are strengthened by the sharing of operational resources and data. Two of the grantees were able to share medication data between their applications because it was enabled by the Common Platform. The limited data types that we had there, and there weren't that many, were sufficient based on the requirements that we gathered, that they were able to do what they needed to do to get their applications to work. A flexible, powerful access control system is key to success, to granting that access to the right people. And I guess ultimately, an open source personal health data repository can be successfully implemented. Given that there's lots of, that there's big players in the market, what is the place for the common platform? First, I think that academic medical institutions, research organizations that are maybe looking to identify some of these innovative ODLs and what the right ODLs are, it's a good fit for them. They typically have the available resources to implement and expand upon existing code sets. They also have the desire and probably the ability to host that data in-house. If control over your data is important, then having an open source solution like the Common Platform where you can host it, you can do what you want, you can change it, is going to be a big plus. Startups is another one. Somebody who's wanting to get as fast as they can to market, they can leverage the Common Platform architecture to get up and running as fast as possible. And then as they get more requirements, either they can implement new features in it or replace them as necessary. And so here are some of the things that we've identified as opportunities for future work, things that we didn't have time to do in round one. Encrypt the data in the database. Right now, this is a research project. The database can be hardened. The services should be hardened against denial of service attacks. Added support for the batch upload of data. Support for additional data types, new ODLs. And also one thing that I think is important is that would help in the adoption of this technology is building platform-specific API wrappers. Right now, all we have is kind of the WSDL, and you can download it, and you can use various tools to build out your client stubs and access the database. But there's lots of hurdles to that and lots of quirks based on which tool you chose, what language you chose. So providing a nice prepackaged set of binary APIs would be key. We are hosting an implementation of the Common Platform. You can sign up for access to it. Just as a note, this is a sandbox. This is just an example. So there's no real patient data allowed in this system. You can sign up through the Project HealthDesign website. The URL is there, and this whole slide deck is available on the OSCON website. Once you enter in your registration information, I review it, and if everything looks good, then we'll create you an account and send you your credentials, and you will be on your way to accessing the Common Platform. Of course, the source is also available. Project HealthDesign required that all of the grantees and the development of the Common Platform make their source available as part of this project. So it's up on the website. You can download the source, a binary distributable, and do what you will. Take a look at it. Happy to help with any questions if anybody wants to dig into the code. Some additional developer resources. If you are interested in looking at it, there's a number here. Won't go over all of them. The top one, the Web Services Client Guide, really will be key for finding out how to start playing with the Common Platform. We also have a hosted sample personal health application that you would be granted access to if you sign up for access. It's just a simple personal health application, kick the tires web application. So kind of an admin portal type of thing. Just kind of shows you the capabilities of the Common Platform. And with that, thank you very much. I'd be happy to take any questions. Yes.
So Project HealthDesign was a kind of innovative granting project in itself, and you didn't really cover that. I think it's really cool. So I was wondering if you could just give a brief description of what that was.
Sure. So they wanted to. I covered it a little bit at the beginning, but what I'll say again is that they issued grants to these grantees to really push the envelope of personal health application development, kind of like an X Prize, if you will. And they really they focused on big sky type of ideas, even ideas that might not necessarily be implementable today. That wasn't really a barrier to Project Health Design accepting the grantees. So they did things like a home health environment where the things that you would do throughout the day, your house would monitor you and would store things as you're moving throughout your day. Other ones were this kind of a mood meter that captured your activities during a day and would help relate that mood score based on what you did, what you said through text messaging and social networking. So these are really big things where solutions may not be available, but the goal was to push the envelope and make new ideas in this personal health space. In the back.
As a platform, you want people to build things on it?
That's right.
What would be like the top 3 things you'd like to see built on this?
As part of the project, we did see there was actual building done on it. Some of the interesting things were we had glucometers connecting directly to it, pushing data onto the common platform. And that data was then pulled down by a different application that would view the glucometer data, and a doctor could review it and make comments on that patient's readings throughout the day. Some other ideas. There was a couple of glucometers. There was also some physical activities for obese patients who are at risk of depression. So it monitored physical activities, via pedometer data, as well as kind of self-reported activities that they did throughout the day. So I went on a walk today. I ate this amount of food. Here's a picture of what I ate. Maybe it could even be encoded with some calorie information. And then that data could all feed back into the second round of Project Health Designs right now is really focusing on making this data that's made available by these personal health applications available to clinicians for clinical use, and focusing on what can we take from ODLs and really apply to a clinician encounter. Yes.
What about expanding into home health? It seems like a perfect opportunity for that.
Absolutely,
area.
absolutely. If any kind of device that could have some plug-in through a web services application, it's a SOAP web service, could upload data to it and make that data available to any number of applications for any other purposes. So it's really meant to be a centralized storage that can then make the data that's stored for a patient available as needed. Yes.
So it seems like in open source we have kind of a somewhat of a format war that's coming in. EvoX is a great PHR application, which is a PHR but takes a modular approach precisely to enable applications like this. Offers many of the same kinds of options that you're talking about. Also, Health Vault, despite the fact that I don't like their license, they do have a somewhat friendly license on their Health Vault API, somewhat friendly, that you could theoretically implement in an open source language that handles this, I think you've got the acronym for it. It's OSDL?
ODL.
ODL.
Yeah.
Okay.
Observation daily living.
ODL. So ODL is not well formed by the standard. So what we're doing is we're creating an ad hoc standard, which I think is appropriate for that kind of thing. I don't think that's a problem.
We're early in the life cycle of defining what these things are.
Right,
So.
and this is the kind of thing where it's not exactly life critical data. So we don't treat blood pressures this way. We've got good formats for that. We've got good standards for that. It's okay that it's not sorted. And emergent standards would be great. But it does seem like there's at least 3 that I know of now. The implicit stuff in EvoX, the implicit stuff in Health Vault, which they do license, and yours, And if I'm going to develop I am developing an open source application that does, that generates ODLs. Is that right?
You got it.
So weak in acronyms. And of course, an ODL doesn't sound like any of the other acronyms that we have all over the place. So, can you comment on that format war? Can you comment on that? Can we not do
you call it a format war. I call it an opportunity for synchronizing and harmonizing across these projects. Definitely agree with you that it does make sense to have this central authority, and I said that that's one of the lessons learned, that there is so far not a standout with regards to where to go for definitions of these ODLs or personal health data types, and definitely as more of these applications start to evolve and merge and come together, that there is opportunities to be able to define in a common place. And this is something that Project HealthDesign is aware of and is not adverse to. If there is a better way to structure the data, adapting these data types. I just to put this in context historically, Health Vault didn't publish their data types by the time that we had to have a live system running, so we couldn't at the time have harmony.
That's interesting. It seems like the other thing that the Google Health guy was saying is that, well, we've got people who are extending the CCR in ways they probably shouldn't.
It's a little kludgy.
They said, Google Health essentially said, we want to do traditional health data and we want to exclude ODLs. For a long time, that was the difference between the Health Vault strategy and the Google Health strategy. The Health Vault was intentionally saying, we'll do standard stuff, but we're also going to let you do all kinds of just whatever data type you want.
They have very discrete data types in Health Vault.
And then Google Health said, we're going to go with health data standards, and then of course, people are misusing them essentially, probably due
because
this type of data. Because
the discrete is not available.
So it does seem like, if I'm a developer and I want to do anything with ODLs, every time I say that, I think I'm saying it wrong. But
you're getting it.
Yeah, I'm getting it. I'm working with you. So it seems like there's no clear path, and that's problematic because what does that do? That makes me want to wait, and that's not the right incentive. So this seems like a pretty critical issue.
And a good opportunity for coming up with a group to define.
You're one of those excessively positive people, aren't you?
Yes.
I have to be. I work in healthcare IT.
Hey, well said, well said. Well,
I guess I don't see, sorry, I didn't mean to, but anyway, if we're having this conversation, I don't see that there's a conflict. Because it seems like you're the front end, or could be the front end, for Google Health and Health Vault.
They serve similar purposes, and the conflict is essentially Health Vault has a way to say it, Google Health has a way to say it, Common Platform has a way to say it, IndivoX has a way to say it. So if you are somebody, if you are electronic health, Joe Blow's electronic health record system, and you want to start saving your data to any of these repositories, now you have 4 times the work because you have to implement this interface, that interface, and define data in different ways. So
medical side where it's been fully defined, that path is pretty well defined among those health vaults.
It's more defined. There's still challenges with semantic interoperability, even in the best.
So positive.
It's extremely positive.
Yeah, that's pretty mild.
Yeah. Well, it's at the end of the day.
I do have a question since we have this gentleman here. This seems like with Health Connect, eventually won't this information be something that Connect will be branching into?
Sure, we have a end-user experience-based layer in the Connect solution. We haven't spent a lot of time marketing it yet, but it's what we call our universal client layer. And so it is focused on these kinds of platforms. So as I'm sitting here listening to this, I'm thinking about the services that are defined there, how we would implement those in terms of do we just import the existing software that we have? Does it require refactoring? It'd be interesting to hear more about the threat analysis matrix that you've done from a security perspective on the platform itself, if any has been done, so that I can understand what are the known security vulnerabilities, those kinds of things. But those are all things that we have to look at everything that we bring into the project, in terms of assessing how we package it and what we do with it. But clearly, this is a level of capability that I think I will have requirements for this from probably more than one federal agency. I was just sitting here thinking about the different projects that are looking at this kind of data. So CARE-CHIPE, which is a CMS project, is looking at transitional data about functional status, which includes ODLs, for people who are in a chronic care setting, moving from, say, nursing home to hospital to rehab center back to hospice or nursing facility or what have you. And so they're looking for functional status indicators, which ties really directly into ODLs. And we have some standards that we've put through the harmonization process for that. But there are a bunch of things that he's talking about here that we haven't gone through that process yet.
Maybe that could be the collaboration.
Oh, absolutely. And that's what we're all about, is forming communities of interest around this.
That's why we're here.
And then getting it through the standards process. And the fact that we've got 4 different approaches doesn't alarm me at all, because we're early enough in the process. Nobody knows for sure what's useful yet. The DIY genomics, the collection of ODLs is probably relevant in that setting to sort out what environmental versus behavioral versus genetic, phenotypic extract, all those things. ODLs adds into that, the richness of the data set, but we don't know yet what's important.
Question back there?
Yeah, I just see on your website, we have something called comparative analysis with respect to existing and emerging clinical data standards and commercial PHR data repositories. So you obviously have thought deeply about this.
We have just a cautionary note on that was written about at the time when the Common Platform went live. So Google and Health Vault have made changes to their system. So just take some of that with the knowledge that they are changing their systems rapidly, and that some things may not be current anymore. But yes, that was one of the things that they Project HealthDesign National Program Office was concerned about at the time, because these things were just about to come out, or just on the verge of coming out. And so what was the difference? Can we is it okay? Should we continue this development work? Should we just drop everything and switch to Google Health or Health Vault, or so they decided to continue on for round 1, and I think we implemented a pretty cool system in a very short amount of time, and it was it was fun. Okay, thanks everybody. Have a good night.